Oh, hey, hi. Yeah, thank you for clicking on this video. That's how I start out every single bit of my videos. It's kind of like my intro. I have been told that the first minute is quite important for viewer attention, so I'll quickly introduce myself. My name is Shitij. I am a batch of 2025 Electronics and Telecommunications graduate. Although I have been working since the end of my third year, so it's been about a year and a half in the industry for me now. As of today, I work as a firmware engineer in an IoT company. I am based in Pune. I have studied my engineering in Pune as well, so it's been about 4 years, give or take, in this city for me. I'm originally from Mumbai, and that's all that you do care about me. Right. As you have read the title of this video, the context is about what did I exactly do in my college career that led me to where I am right now. That thing which I did is college robotics. I was a part of this team right here, Team Automatons. We are a collegiate robotics team. I'll quickly put on my glasses because I can't see shit. Yeah, so we are a college robotics team that take part in a competition called as Robocon, and the video is about my time there. How did I get recruited? What did I do? How did it help me? Get into embedded systems and embedded software, and a bunch of those things, right? So if you are an electronics graduate or an engineering student, and you would like to hear about my story and my journey, watch on, right? Yeah, there is going to be no editing in this video, as I still don't know how to edit videos. I still haven't got a tripod. I need to do a whole lot of stuff, so this is probably going to be a yap session, to save you a whole lot of time if you are not interested into hearing a guy sit in a chair and talk for about 20-25 minutes. Now would be a good time to click off. Either way, I really appreciate that you are giving your time of the day to me, and without much more further bullshit, I'll just start, right? So I'll start with how did I get recruited into the robotics team. Uh, when I was in my first year, I met a guy from the fourth year of our college. He was a mechanical engineering student. We started as a basic conversation. It was through a friend of friend. You know how juniors meet seniors, right? So he was a friend of my friend, and we had a very brief conversation where he asked me about why did I pick engineering, why electronics and telecommunications. I had a decent enough percentile where I could have potentially gotten CS, or that is computer science or IT, but I picked DNTC. So he was quite interested in what's my thought process and reasoning behind it. And I mentioned that I would like to work with PCBs, I would like to work with electronics. That's why I choose electronics in the first place. If anyone is not from India who's watching this video, and you have a shock, please don't be. It's a whole other story, right? So that guy, the fourth year guy, the mechanical engineering student, he said that, well, if you are interested in working with electronics, I am a part of a robotics team that our college has. If you would like, come down and visit. I was like, hell yeah, I would love to do that. Let me just go down there and visit. And it was about like with the fourth or fifth day of college for me, where I went down to the actual pit of the robotics team. I stepped in and looked at what the hell do these guys do. And yeah, to say that I was blown away was like would have been a massive understatement, right? I mean, the minute I stepped in, I saw a quadrop robot. You might have seen one from Boston Dynamics. Yeah, so that was about, I think, the 2020 Robocon theme. So that robot was being tested just for R&D purposes, which is the first thing that I saw as I walked into the robotics team's lab, as we call it, the pit, right? And yeah, that was the moment I said, dude, I have to get into this team. I have to do whatever it takes to be recruited by these guys, right? So there was a recruitment test, MCQ test, which was based on our basic understanding of physics, of programming, of a bit of robotics, and some common like logic based questions, right? We all of us Indian guys know what logic questions are. So I smashed the test. There was a interview after that. Those who score above a certain threshold. I think it was the test was what, 20 marks. The passing criteria was like 15 or 16. I scored somewhere around 18, so I did get through. The interview round was, amazing for me. It was exactly like this. The way I'm talking to you right now, I was talking to a couple of seniors in the robotics team already, and I was among about 46 people that were picked out of about 200 people. The robotics team takes in a whole lot of people because they know that about 60% of the recruited candidates end up leaving within the first 2 months. Not me. I was like, yeah, I'm staying here once I get in, right? So I got in my first year itself. I believe it was in my second semester that the team's activity started for the new recruits that my batch had. And yeah, that was the story of me being recruited. From here on, I'll talk through the 3 years that I spent my first year, second year, and my third year. I was there in my robotics team officially till I got an internship, which was in my sixth semester. After my sixth semester, no, in my final year, the seventh and eighth sem, I was unofficially supporting the guys there, by helping them out as and where I could, as every single senior does, to be fair, right? So cool. In my first year, what we had was the foundations, because the team guys know that the people that they have recruited, they're dumbasses. They know absolutely nothing about anything. They're just 12th standard JEE traumatized kids, right? So what we learned was the basics of three major domains or three major branches that we have, which is mechanical, electronics, and computer science. The philosophy of this team is we are a cross-functional team. Therefore, every single member needs to know at least the very basics of the three domains that end up combining with each other to form robotics. The three domains being, as I said, programming, mechanical engineering, and electronics engineering, right? So we don't discriminate that, you are a CS student, you don't need to learn or know how to use a power tool such as an impact drill or a cutting machine or a hacksaw, right? Even a com science graduate should know these things. A mechanical engineer should know how to solder or desolder a very basic circuit, either on a breadboard or on a perf board or something like that. That's the philosophy of the team. So all the first year students, regardless of their branch, are given a common syllabus which includes the basics of all three domains. Basics of programming, the very fundamental things like what is a function, what are keywords, what are operators, all those sort of things. Basics of mechanical engineering, which includes hands-on with chains, jigsaws, hacksaws, power tools like drills, the different types of screws that we have, the different types of nuts and bolts that we have, and then the basics of electronics. What is a resistor, transistor, capacitor? How do you use these things? What is a transistor? What is a BJT? What is a FET? Just so that any recruit that comes into the team has to be of the mindset that they are not a com science student or electronic student, but they're a robotic student. That's what the whole point of the first year was. So we get about 3 to 4 sheets. We call them syllabus. The first, second, third, and fourth, all in sequence. You get the next one once you complete the first one. So the syllabus 1 has the basics of all these things. Syllabus 2 has a bit more advanced concepts again of all the three domains, right? The third and the fourth, they become a bit branch specific. They have a bit of sensor interfacing, they have a bit of Arduino programming, all that stuff. So the student in the first year, when they get recruited, they are expected that within 5 to 6 months they will at least have a hands-on knowledge or a hands-on skill set on working on any three domains. They can write a function in Python or in CPP or in C or in basic C. They can solder or desolder a very basic circuit. They know what a resistor and a transistor looks like and how to differentiate between both of those things, and they know how to use a drill, how to use a hacksaw excuse me, how to use a jigsaw and all those things, right? That's the first 5 to 6 months. Now then comes the summer vacations. I was an idiot. We had a 3 month long summer vacation because a whole lot of people from my batch in the first year had failed in some subjects. So the college decided to have a special summer term for those 3 months. Long story short, everyone else went home. I took special permission from my college to stay in the college hostel and keep working at the robotics team. Why did I do that? It's a long story. I'll save it for the rest of the video, right? So the gist of my first year was the basics of everything. Then as the second year was about to start, we got our domains assigned to us, right? And for electronics specifically, since I'm an electronics student, we had 4 domains. We had circuit designing, We had PCB designing, we had embedded software, and we had something which we like to call as the Swiss knife domain, where you are not particularly assigned to a single domain, but you have to know every single bit. So you don't get the responsibility of, for example, designing a protection circuit or over voltage or a over current protection circuit. You don't get the responsibility of writing software for a particular mechanism. What you get is to be the handyman of the team and work across every single thing. So if there is a person who is really enthusiastic about learning every single thing that they can, they are assigned to this Swiss Army knife domain. Anyways, that's enough of yapping. Coming to what I did, I got assigned into the embedded software domain, and my job essentially was to write firmware or write software for one, the mechanisms that we had on our robot, and two, the chassis or the navigation code of our robot. So how is the robot supposed to move, how are we supposed to control it. That was my that was supposed to be my responsibility, right? So when it comes to embedded software, this is how I started out. I started with the classic 8051. I actually completed a course of assembly programming in 8051, where it started from the basic move, instruction, add, sub, mul, no, the very basics of assembly, opcodes and instructions. And it went all the way up to generating a sine wave on a 8051 using assembly programs. The reason for learning 8051 and doing it in assembly was to understand the very fundamental gist or the core of embedded software. You have to understand, or at least get a taste of assembly to appreciate what C does for you. You have to work in C to appreciate what Python does for you. That's the core philosophy, right? And the second thing is, there are concepts within embedded software and embedded systems, such as timers, such as UART, such as the whole communication protocols. Now if you directly try and understand them on a 32-bit architecture microcontroller, that becomes a lot tougher for someone who has never worked with these things. So the philosophy is, you give them a 8-bit microcontroller like an 8051, and you let them explore the very basics of microcontroller architecture, of things like timers, such as watchdogs, such as how to generate a sine wave on these 8-bit systems where the hardware is limited, and it becomes a bit easier for a newbie like myself in my second year to digest these concepts, right? I started out with 8051. I moved on to PIC 16. Again, similar concept, just a gateway to the 32-bit architecture that we targeted to work with. Once I've had my basic teeth cut out on 8051 assembly and PIC, which I did in embedded C, I was given an introduction to the Arduino ecosystem. I worked with a whole lot of Arduino boards, by the way. I worked with Arduino Uno, Arduino Mega, Arduino Giga, Micro, if I remember it being called. That was a very, very small Arduino board. I worked with Arduino Duo. I worked with a Leonardo board that we had, and I interfaced every sensor that you can think of. I interfaced a temperature, I interfaced a time of flight laser sensor, I interfaced a ultrasonic sensor, an IR sensor, I interfaced the motor drivers such as I don't remember the name. Oh yeah, BTS 7960 motor driver. I'm sure every single robotics kid here in India knows what a BTS motor driver is. It's a DC motor driver. I had my share of sensor interfacing, and then once I was fairly proficient with sensor interfacing, I had given tasks to combine 2-3 sensors into a very small system interfacing. For example, make a ultrasonic radar with a functioning GUI on your laptop. That was about a small project that I did for like a month in my second year. Arduino, basics of Arduino, sensor interfacing and all that. And once that was done, I was given an STM32 development board, and I was told by my seniors that you have a year, learn about STM32s as much as you can. We have certain objectives for you. We want you to go through the bare metal software route. in order to learning STM32. And the end goal of STM, of you learning STM, is to one day use this microcontroller in our robot. Why? Because after, I believe, 2019, no one had touched that STM32 board. So I was the first one in about 3.5 or 4 years in order who was given the responsibility to work with STM32 and try and integrate that in our robot. Yeah, that's what I did in my second half of second year, which was my fourth semester and a bit of my fifth semester as well. So I had about 8 months of working with STM32, and I did everything. I made my own programmer's model. I wrote my own device drivers for GPIOs, for RCC, which is reset clock control, for communication protocols such as SPI, I2C, UART, USART. I did some CAN interfacing. I did some timer interfacing. I generated PWMs, and then once I had enough experience of writing code for STM32, every single sensor that I had interfaced with an Arduino Uno, I interfaced it with an STM32. The goal of the team, or for me to work on STM32, was to essentially develop software and develop a system where STM's boards could be a drop-in replacement for Arduino boards. That was what I was working towards. I spent a good 8 months and I did about 3 Udemy courses from Fastbit EBA. I might link them down in the description of the video. Right? I did those courses. Purchased from Udemy. I actually did purchase them from Udemy. I thought pirate them. Do not pirate Udemy courses, please don't. It's like 500 rupees a course if you wait for the right discounts. Anyway, I'm yapping off track. Yeah, I worked with STM32 boards, and that essentially led to me cracking an internship, because my experience with bare metal software with like 32-bit microcontrollers is what was needed in the industry, and that is how I got out of the team as well. Now, my exit from the team was not mutual. It was not very healthy. There were fuck ups and mistakes from my side that were too much for the team to tolerate. That being said, I do not agree with the way that I was kicked out of the team. Spoiler alert, I was kicked out of the team. But yeah, essentially there is no love lost. I attribute every single thing that I have in my life, at least in my career right now, to Team Automatons. They also have a YouTube channel. I will link them down below in the description along with the Udemy courses. Promise this time. And yeah, to close out this video, whatever I did in these 3 years, it was my second interview of my life. The first one I failed badly. The second one was at a German automotive company that has a R&D center in Pune. I believe I had 2 rounds there, and it was an hour and a half each round. So total of 3 hours of people with 15 years of experience, 10 years of experience in the automotive industry, in automotive field, asking me, a third year student, about what the hell have I been doing in my college. And I promise you, for the entirety of those 3 years, I talked about one thing and one thing only: my experience at Team Automatons, my experience at Robocon, my experience at working within this team. So the message that I want to convey through this video, through this yap session of, I don't know how long, it's been about 25-30 minutes, I'm assuming, right? The message is, whatever I did for the 3 years in this team, bunking lectures every single day. Spoiler alert, I have never had above 50% of attendance in any of my 8 semesters of college. Yeah, I still graduated on time. So that just goes on to show you, how important this team was. And yeah, I used to bunk classes every single day in order to spend time at the pit of Team Automatons. My schedule for the 3.5 years of college that I spent working within the team was wake up at 7:30, open the lock of the lab of the pit, start working at around 8:30, all the way till 1 a.m. 2 a.m. in the night, go back to the hostel room at 2 a.m. in the night, catch up with some college work, make coffee that is strong enough to kill a horse, right? And sleep at around 4 a.m, wake up at 7:30 a.m, 3.5 hours of sleep every single day, and get back to the college work. I was a bit of a loner during my time at the team, since I was the only one working with an STM32. I did not have anyone from my batch who was doing the same things as me, so I had to work extra hard. And the culmination of all of this work and all of this time that I put in into my robotics team was that I was the second guy to crack an internship in the industry from my batch. The first guy was my teammate from the same team. So, and this has been a legacy since my batch. So, batch of 25, batch of 26, and batch of 27. The first people from the electronics department to get an internship, a paid internship, where the company pays us and we don't have to pay anything to them. I'm taking a shot at all the course sellers, but anyways, right. For the past 3 years, the first people to get an internship have been from Team Automatons in my college, and they have been from my domain. So I was the second guy from embedded software 26 batch. The first person to get an internship was from my domain, and then from 27 batch the first person to get an internship was from my domain as well. So it's a small legacy that I believe I have left at Team Automatons. And to close out this video, if your club or if your college has a robotics club, not just robotics club, but Formula student team, or a Baha SAE, Baha Supra team, or a Tiffin team, or a drone making team, or any sort of collegiate club, if your college has one of those, I would highly recommend, regardless of your branch, that you do go and join them, especially if you're in a tier 3 college, because I'll be very honest with you, the college and its syllabus won't get you a job, it will just get you a degree. What will get you a job is what you learn in these clubs. And I for once can speak from experience. I can guarantee you guys, whatever I know, whatever I have today, the job that I have, even while I was in college, the internship, after I got out of college, the 2 off-campus offers that I have, cracked and joined, none of it would have happened if it was not for this team right here. So that is what I would like you to take away from this yap session of me. If you have made it to the end of this video, please drop a comment. I would personally thank you for making it to the end. I know that I need to edit my videos better. I need to learn how to edit my fucking videos to get started. But I believe I've spoken enough. I'll see you guys in the next video. I don't know when. I'll drop something related to embedded software. Do like, share, comment, and subscribe, all that stuff. Okay, bye.